Thank you everyone for attending this webinar. I'm actually very happy that before we even started, we already had 7 people waiting. So thank you very much for attending. My name is Mogdad Abdeen, founder of the Clean Energy for Africa initiative. And tonight we're very happy to be hosting another webinar in our webinar series by engineer Mogdad Abdeen, who will be speaking to us about the applications of renewable energy systems for decentralized power generation in developing countries and through a case study in Sudan. A quick overview for those of you and first time who are joining us. And first thing, inshallah, I'll be speaking in English. The webinar will be in English because we have some international attendees. So that's why the webinar will be in English. Clean Energy for Africa, just for those of you who are joining us for the first time, it's an educational platform that aims to be a common place gathering for professionals, students, researchers interested in renewable energy and its applications, especially for sustainable development in Africa, to share their experiences, to share different articles, to learn from each other, and to empower ourselves. This is the whole idea of the platform. We started since around 4 months ago, a webinar series where we had several speakers talking to us about different topics in the renewable energy industry, from biomass to entrepreneurship, to solar energy, to some research case studies like the one that Mogdad will be presenting for us tonight. So a quick introduction or biography about our speaker. Mogdad Abdeen is a graduate sustainable energy engineer who graduated from the University of Strathclyde in the UK. He recently graduated actually a few months ago with the first class MSc degree in sustainable energy engineering. And he was also the winner of the SFC scholarship for 2018. He holds a BSc degree in petroleum and natural gas engineering from the Sudan University of Science and Technology. Mogdad is deeply passionate about green energy and sustainable development, particularly regarding strategizing for developing countries. His goal is to become a member of a dynamic pioneering company working towards innovative energy solutions, especially in the renewable and low carbon field, whilst also working towards being a professional registered as a chartered engineer. So yeah, basically he's actively looking for jobs at the moment. So if anyone has an opportunity, this is an excellent candidate that you could consider. Mogdad also was a member of the Uprising Leadership Program, which is a development program, graduate environmental and leadership development program in Cardiff in the United Kingdom. He worked in several places, mashallah. I'm looking at his CV right now on LinkedIn. It's honestly quite impressive. He also is registered and licensed with a number of organizations. For example, he's an associate member of IMEI, Energy Institute. He's also a licensed engineer member of the UK Association of Energy Engineers, and a number of other affiliations. He's also very active in volunteering, and he was working for over a year with the Welsh Refugee Council as a case worker assistant. He also worked with the Rotary International, which is one of the largest organizations, as a community volunteer for over a year. So pretty impressive resume and career background of that, inshallah. So today, I believe what you'll be speaking to us is the summary of your master's research work. So we look forward to learning more about your research and how it could be applied to Sudan and other developing countries in Africa. So Mogdad, the floor is yours now.
Oh, thank you, Mohammed. Thank you very much. I appreciate your introduction is quite long, to be honest. And so this is me, and I'm going to speak actually about my dissertation. So I have conducted this dissertation for almost like 3 months last summer holiday, working to develop renewable energy projects for my homeland country, Sudan. So this project is basically analyzing various energy solutions, and we can implement it in Sudan to overcome the consistent electrical. Yes.
Sorry to disturb you. I was just trying to record on my PC, and I think
Okay.
can you do the recording on your PC? Is it possible, just so that we could later on upload the? Because I'm trying to do it, and I have to request permission from the host. Sorry.
Okay. Record. Yeah. Okay. Record now.
Okay. Perfect. Let's keep on going. Sorry to disturb you.
That's fine. No problem. All right. Yeah. So as I said, this is my master dissertation. It's about like a project in Sudan. So basically, the project is basically to implementing like a small scale of renewable energy solutions to overcome like consistent power supply issue in small towns in developing countries in general. But this is the case study particularly in Sudan, in a town called East Soba. Basically, is kind of like 22 kilometers away from Khartoum. So let's go through it like part of part. But first of all, my apologies for anyone actually in the beginning. It's going to be a lot of technical and knowledge. So my apology in advance if anyone from non-engineering backgrounds. I apologize for that in the beginning. So let's start. So generally, before I speak about the developing countries, let's just speaking about overall what is the energy supply issues in developing countries. So basically we can divide them into various issues. The first one is basically unreliable grid infrastructures, and that could be like a linkage for different issues. Every country got its own energy and power supply issues, and that's basically because of the very old outdated grid. And the main problems could be from that is the load shedding. So this is going to be my project actually about the load shedding. The definition of the load shedding is basically about how the basically the consistent power outages. So okay, can you hear me now? Sorry. Hello.
Yes, we can hear you.
I can hear you, yes.
I can hear you. Go ahead,
okay.
Continue.
Okay, sorry. Okay, yeah. So the second big problem is the load shedding. So we're going to speak about the consistent power outages in Sudan, particularly for these towns and the reason behind that and the impact. So in general, if we want to the vast majority of this impact could be could impact the quality of life. So we can break this down into disruptions for jobs, as well as disruption for the national health service in Sudan, and not only that, but the education disruption as well. So there is a various issue could be linked with the impact. But however, the reason behind that is basically the political instability. So the central decision from the government could be one of the reasons for leading to the weak infrastructure of the grid, or generally the energy supply issue, the financial difficulties, lack of expertise. This is particularly the case of Sudan. There's a lot of lack of technical expertise. Also, the could be one of the reasons the unprecedented rapid urbanizations. So the urbanization actually affecting most of the African countries, and particularly nearby countries like Nigeria, Ethiopia, Egypt. So there's a lot of pressure on the national grid. So we can talk about it in detail through it. So the evaluation of options, what have we got then if we got all these type of problems? So we either have to reinforce and upgrade our grid networking, like the transmission lines, the distribution lines, and that could rely heavily on the government, so the central decisions, which is quite difficult, to be honest, in a modern society. If you want to implement energy projects, that will take a lot of time. So the second options we got is having off-grid system, a small scale grid off-grid systems. So we call it here in UK the community system, the community energy system. Basically, you don't have to rely on the central government. This is completely a decentralized energy system. It could be one of the options to sort out the problem in a specific location. So the consequences for this system basically could be lower capital cost, less political involvement, because you don't need the government to involve in any federal government to involve in decisions like small energy solutions. The time scale of it could be vary from medium scale to small scale, and you definitely as well you're going to use the local energy resources. So this is the other options we're going to go through it, like the combination of small scale systems in this project. Move to the next slide. This is just overall of the goal of the project. So the project basically, the aim of the project is to design a strategy. This strategy could provide three important points: reliable power, sustainable power, as well as the affordable power. So we can call it sustainability. Okay, this strategy is supposed to be built on an integrated system, okay, to overcome the supply issue in a small town in Sudan. So we can say, in order to implement the sustainability, you have to have three important points. You have a technical expertise, you have a technical analysis that could be reliable power supply. You can have environmental impact assessment. This is the sustainability and reducing the carbon emissions. And the last options is basically the affordability of the power. So it's very important to have a lower cost power. People can could pay for it and they could benefit from this power. Moving to the research scope. In any research, you have to have a limitation or your boundaries basically. So in this research, the boundary is I'm going to focus on electrical supply only. So to try to decarbonize the electrical system in Sudan, that involved with residential, commercial, as well as the public service only. Okay, so I'm not including any transportation sector here in Sudan. The thing is, because the government hasn't published any short-term or medium-term goal for 2030 or 2025 to basically implementing electric cars. So this is going to be a bit different from my research. So that's why I include I excluded the transportation basically. The heating system, basically, there is no heating requirement in Sudan. We're not required to produce any heat. The country is very hot country, basically. The climate is very hot. So we're not responsible for any heating sector. For the gas, yes, could be, but it's not here in this research. So I have to make very clear point here. The dimension of this research is focused only on electrical supply for the residential, commercial, and public sectors, okay? And it's going to be on a scale of the town scale. So it is not a very small scale, and it's not a nationwide scale. So we have to be careful about this point as well. It's a medium scale, on a town scale only. So it's not utility power generations, okay? So this is the research scope. Going through the case study, quick information about what is East Soba. Basically, East Soba is almost 22 kilometers away from the capital, Khartoum. How many inhabitants? Basically 20,000 inhabitants. And the vast majority of the houses there is either terraced house or semi-detached houses. Average of 5 people per house, 4,000 houses in the town. The overwhelming majority of the income, we can consider it people who works in agriculture sector, catering sector, and as well as they are animal traders. And another point is really important as well. The city is connected to the national grid. So this is really important to put in your mind. The grid is covering the city, but there is a consistent blackout, and we're going to speak about how we overcome this blackout. You can see here from Google, this is the location of East Soba. Moving to the another slide. So what is the specific power in East Soba? So there is a specific power here. We can talk about it. Basically, there is a big gap between the demand and supply. So that could cause the reason behind that is because of the schedule, continuous load sheddings. The average load shedding in this town is between 8 to 10 hours a day, which is quite high, to be honest, in a developing countries. I know there is nearby countries the average power cut is basically more than 8 hours, but this is the average we can take. And the reason behind that could be linked to two things we found from this study is the continuous transmissions and distribution losses is actually accounted to 20 to 25%. And which is really quite hard as well. The diesel generation, the diesel generation is quite high as well. So the price of diesel is not quite sustainable. So we can put it as the options, but it's a problem basically. You know, people can't access to diesel alternative generators. So they have to rely on the only source of power is basically the grid. So the case study methodology, the methodology I actually followed here is basically, so you have to collect the data, firstly, the data, and then estimating the energy demands in the city, and then analyze this demand and try to figure out, like, you know, any assessment of local productions of, you know, energy resources, and as well as the modeling and energy demand and supply. So then we can make like a clearer pictures about the supply. But the last point is basically examining the proposed systems. So that could lead to the overall. Yeah.
Sorry to interrupt. Just a quick announcement. Everyone, please make sure your mic is muted. Just make sure your mic is muted so that the audio is clear from the speaker and we don't have any interference. Yes, thank you, everyone.
So in any research, for, you know, the methodology basically is that you have to collect the data. You need the demand data and then optimize this data and put it like in a central database, and to describe what's going on exactly behind this town, and then you're gonna have, like, you know, demand and supply matching that could give you, like, you know, and you're gonna use the software. So I'm going through it one by one. So this is just overall of the methodology I followed in the research. Moving to the next slide. So let's start by the demand analysis. And this is really like a genuine information about the town with the real data. So we're going to go through it like an example of as basically, let's say as example, yeah. So let's go through it. So the understanding of the demand in the town, okay, why did I use is basically quantitative and qualitative survey. I use as well expert opinions, like in engineers working in the Sudanese, you know, electricity, you know, the Ministry of Electricity, as well as the, you know, data from other comparable case studies. The reason I use the qualitative and quantitative survey is basically qualitative and quantitative survey can give you like an overall, you know, understanding of the demand, because it links usually with numerical analysis and with the behavior of the, you know, the behavior of the consumers. How do they usually consume the power through the, you know, through their, you know, basically in daily lives. You can see from this graph, the vast majority of the demand comes from the residential, like over like 54%, which is half of the demand in the town basically comes from the residential. And so the vast majority of it goes to the, you know, 4,000 houses, you know, consuming the demand. For the premises, this is basically breaking down the premises in the town. So we can see 4,000 like houses in the town. There is 3 schools, 5 restaurants, 4 mosques, and like there are 4 supermarkets, and as well as like a medical center and pharmacy and 1 police stations. When I collected the data, basically I had consulted, like, you know, an expert in this analysis. So the thing we found that basically I need to know the average before I can start analyzing the data. I need to do the average for the typical house in a summer and in a winter. We found that is between 550 to 750 kilowatt hours, and in winter basically is less than that. The reason behind that is in Sudan, the summer, basically the consumption of power in Sudan during the summer times is far more greater than the winter. So also you can see for the school, medical center, the supermarkets as well, this is the average consumption, okay, in summer and in winter. The reason I say that is because it's going to be quite helpful in analyzing the data when I put them all in the software. I'm going to talk about it later. Let's start by the residential, actually, the residential sector in Sudan. So the residential sector, there is actually we have collected like electrical bills for the last 12 months for like 11 houses, and we consider as well the houses, you know, the electrical appliance for every house, and the consumption behavior. So the consumption, you can't know the consumption behavior unless you do like a qualitative survey. So you ask about when do you use the when you turn on your heating, when you turn on the air conditions, the washing machine, the van, the oven, you know, the microwave. So you need to know the behavior of customers. So we have to do like assumptions as well as, you know, collecting, you know, asking people as well. So the average typical house in this town particularly is we consider as a 2-bedroom flat or 2-bedroom house, like 1 living room and 1 kitchen and 2 bathrooms. And here we how we put usually the survey, or we put the calculation of the appliances. So you can see it's very clear actually. You see the power rating and the quantity of the power, as well as the total demand, and the usage per day. For like, let's say, you can see that the vast majority of the consumption comes from the air conditioners, and you can see the daily demand of it, like 10 kilowatt hours. You see from the table here on the right side. So overall, this is like a typical survey for like a small house. It's 20 kilowatt hours a day in the summer. Okay, just to put it in your mind, because it's going to be quite helpful when we analyze the other, like, you know, part of the consumptions. Is another things, when after you collect the data, you have to do like optimizations. Why I did optimization? Because you have to monitor the power per day, like, you know, how the power is going. An example here for the chart, you can see from this figure, during the summer, the vast majority of the consumptions from 9 o'clock in the morning till like you know, let's say 6 o'clock in the evening. So you can see people turning on their heating, turning on the light, you know, cooking, you know, using the electrical appliance. So you see the demand is basically jumping up. The opposite in the winter. So you can see the peak of the demand is not quite high. So it's actually around like, let's say, like, you know, less than 1,500 watt. You know, this is the peak. I'm speaking about the peak. Okay, it's very important through the residential demand data optimization to know the peak of the day. So when you size your system, you have to make sure that you cover the peak. That's why I considered in my hourly consumption values. So after you collect all this data and you actually do optimizations, and you consider the human behaviors, the consumer behaviors, the appliances as well, and their working hours, and you put it in a central database. So the total demand of the towns, okay, you can see it's 27 gigawatt hours annually. We have considered as well like a 5 to 10% visible like fluctuations. This is like error. You have to consider it, you know. I don't think so. I've never seen like any study or like a research without any error, like, you know, percentage. That's why I say that, is because it's really important during any calculation or the software, when you put all this data, you have to make sure that you have at least like, you know, error range 5%, 10%, that, you know, according to your studies basically. So the analysis of the demand included the residential, commercial, and public sectors. So the details about the schools, details about the pharmacy, details about the medical center in Sudan, in the city. So when you collect all this data and you gather them, you put them in central database, you can see the performance. Okay, I'm going to move now to the supply side. So before I talk about the supply side, so let me just consider like a small point here. Yeah, let's talk about the supply side. So I did like an assessment of the local renewable energy resources in Sudan, particularly in this town. So you can see the solar is actually great for Sudan. It's a perfect system in Sudan. So you see the average in Sudan, the average summer consumption in Sudan basically is like 7 kilowatt hours for every meter square per day. This is the average, or you can see between 6.2 to 6.4. It's still quite high. You can see from the picture, you know, the vast majority of the Sudanese areas, you can see is could be suitable to implement solar energy basically. So this is perfect scenario. It's great, and one of the options we have explored the solar. I'm going to talk about it later. You can see the average as well here from this, the monthly average solar global horizontals. This is from NASA, by the way. So the average in this town, the average solar radiations is like 6.4 to 7, which is quite acceptable. And no, it's not just acceptable, it's very excellent, to be honest. So this is the options one. For the there is another renewable source we can speak about, the wind analysis. I did just to check the annual average wind speed in Sudan, and the average between like 5 to 6 meters per second. So it is average, I would say. It's not quite high. Like here in Scotland, for example, in UK, the average wind speed, okay, is more than 9 meters per second. So comparing to Sudan is nothing actually. It's very high. So the wind in Sudan is affordable, is okay, but it's not the priority for this research because of the wind speed. When you measure the wind speed, there is international what do you call it? There is international level for it. Like you have to measure the height. Like either you consider the height as like 50 meters or 80 meters or 70 meters. In Europe, here they consider it as 80 meters, but the vast majority of African countries consider it as like 50 meters. And then you measure the wind speed through that height, basically. And the pictures indicate this thing. Go to the biomass, and it's really important as well to explore it. And there is 2 types of biomass. There's a gasification and aerobic digestion. So the gasification is very famous here in Europe, but the aerobic digestion usually you see it quite a lot in rural areas where there is like organic waste. So basically you turn the organic waste to more energy. In this town there is like more than 200 animals. Average of 17 kilograms of manure, per animals. This is as well international rate of like between 15 to 17 kilograms. We found that there is more than 20 agricultural land. The average land could reduce like 250 kilograms of waste per land. So if we calculate the overall of the organic waste in the city, we found that almost is like 5,000 tons per annual. It is, I would say, average, okay, and it could be increased more. I will give some advice how to increase. Usually, when you do a feasibility study for a biomass, for organic waste particularly, how to increase. I'm going to speak about it later. But this is basically how to break down the organic waste in the city. Either comes from municipal household waste. This is the human waste. The food, the vegetables, the meat. However, I didn't include the sewage analysis. So there is a lack of details in Sudan about the sewage, and it will take a lot of time in order to actually analyze it. We didn't find a data, so I didn't include the sewage. Okay, the draining system basically. The animal manure as well is very important to talk about it because you can see it represents almost like 23% of the feed stock in the city. So, and also the farmlands waste. So this is the main 3 types of the waste. So we can conclude this part about the energy generation assessment. So we did assessment for the solar. We found it's excellent annual radius, 6.3. It's great, excellent. We're gonna consider this system. Biomass analysis for the anaerobic digestions. We found that 5,000, almost 5,000 tons annual. And I did as well analysis for the diesel. So just to check the price and the fuel supply, we found that it's not green actually. It's from fossil fuel resources. So it is not going to be considered because one of the main objectives for this study is to have a sustainable resources that could be implemented as a part of the system. I did analysis for the wind energy. We found it average, like let's say 5.3 meters per second. There's a lot of countries, nearby countries, have a greater wind energy than us. So it's not an option for this town particularly. It might be visible for other towns, but for this town is not visible. I did analysis to implement if there is any possibility to have a hydro, like a dam on the Nile. It's very complex, to be honest. The reason behind that is the basin of the Nile is very curvy, and the area is very touristic area. So I don't think so the government will take a decision to implement another dam in Sudan. So this is the thing. I completely neglect this part. So we're going to focus on solar and biomass to create like an integrated hybrid system that could be implemented for this town. This is just an overall, analysis of the supply side. Let's go to another part of the methodology, which is going to be the modeling. So when you select the modeling software in Strathclyde University, there is we had a group of doctors. They did like an intensive analysis how to choose the most energy modeling softwares, and they actually break it down from 51 modules to almost like 15 softwares, and they break it down the reason for selection. So I highly recommend this study. I put the link down here so you can follow the study, and they actually put a reason how to select basically an energy models. So at the end, I just concluded that the most important models or the software for me is going to be the Homer software, is hybrid optimization model for electrical energy. It's basically American software, and I've also used AD calculator, aerobic digestion calculators. This is software has been developed by a collaboration from Strathclyde University with a local agriculture company here in Scotland. So, and I gave you the basis, the criteria how to choose a software. Basically, you have to make sure that you know your generation capacity. Before to size your system, to make sure that how is my system is going actually to be, and the configurations of the system, the scale of the system as well, the demand supply data input. So you have to consider all these details in your analysis before you choose your software. Okay, I really highly recommend this study. Okay, you can go through it, conducted by Strathclyde University, and to choose. If you are a student looking for a software and you're just confused about which one to go for, I recommend it for you. It's a really great one. So let's start by the solar, PV, the photovoltaic. So in order to have a PV, there is a two type of operational system. You either connect it with the grid, like a grid connected method, or having a single solar system, basically without any consideration to the grid. So you're completely ignoring the grid. So in this study, what I did is basically I've considered both of them. So just to make sure that people can understand it, what the configuration, the main elements of the system. You got the panels, you got the inverter, you got the power lines, and for the standalone system, you got the solar balance, you got the battery, you got the inverter, and you got the charger control. But there is a very important consideration for the losses. The temperature, any high temperatures, over the 25 degree, it will cause 10 to 20% actually losses. So I have considered in this presentation, and also the dirt and dust from vast what do you call it, other studies, they have considered that could block the sun, and we have also put into account the DC to AC losses is basically 10 to 20 to 12% percent of the losses of the conversions. So this is how the system works basically of the PV, the solars, and then you convert it from DC to AC through the inverter, and then you have the line going to the city directly to the domestic line. So you have to cover because the system is automated system, will work directly with the load, and if there is any surplus, it's going to be sent back to the grid through a meter basically. So this is connected. This is called a connected grid method. Okay, which you're going to focus highly on it in the presentation. The aerobic digestion system, this is another part of the hybrid system I'm recommending today. Let's just give so you can see overview of the aerobic digestion process here. The principle of this system is basically, it's very clear. It's actually breaking down the organic waste. You're going to break it down by microbacteria. So in a sealed tank, The temperature in this tank is in a range between 25 to 40. This is if you follow the mesophilic type of digester. There is a two type of digester, either mesophilic or having like a thermophilic. In this one is going to be mesophilic, okay? You're actually producing a biogas. So the idea is you produce a biogas. This biogas can be converted to electricity or heat, and then drive the CHP, the combined heat and power, and then it can be exported to the grid. So this is an overall of the anaerobic digestion system. It's a very important system. It's easy to implement. I'm going to talk about how to do the technical analysis of the system. This is just like to understand the process before we go deeply on the technical details. The biogas output, the output income basically of this system, the biogas is basically like 60% of methane. So this gives you indication that you could actually have more electricity as long as there is more biogas on it. Internationally, I remember the average 1 meter cubic, I think, for biogas could generate like 2.6 kilowatt hour. So it is kind of average and acceptable figures. So before you do any modeling, so you have to make sure that you have the what do you call it, the existing current system. So I have to model the system in Sudan, in this town, okay? Before I could recommend any system, how you would recommend any alternative energy systems, and you don't even know the system or how the system works. This is a schematic of the current system in this figure 41. You can see the grid supporting the East Toba town. The peak of the town is almost like a 10 megawatt. This is the peak. I'm speaking about power, not speaking about energy, like 10 megawatt. And you can see the total demand is almost like 75 megawatt per day. So I have to make sure when I design a system, I have to make sure covering both the energy and the peak, okay? And when we go to the base models, configurations, description for this model, you find that the productions coming all from the grid so it's covering all demand is from the grid is 27 gigawatt hours per year. The capacity factor is 100% because there is no any renewable penetration, is zero basically. I'm supplying through the grid at the moment. Is the electricity is coming from either like thermal sources or hydro sources. So the cost of electricity in Sudan basically is 0.16 at the moment. This is the production cost, it's not the selling cost. The selling is actually fluctuating because of this subsidy policy in Sudan. So we can't know exactly the price, but I know the production price is 0.16 dollar per kilowatt hours. The grid emissions, you can easily calculate the grid emissions through the software. The current grid emissions going to the town is almost 632 like gram for every kilowatt hours. Okay, so when we calculate the total CO2, this is you find a lot in a scientific research, like they speak about the total annual CO2 levels is 17, almost like 17,000 ton a year. Okay, this is an average. So after we model the system, so we're going to go through it like, the power performance. So you can see from 9 o'clock to 5 o'clock, the grid is down. So there is a consistent blackout in this town. So every day, this is a typical day. That's the typical day in the summer. We took an example of 26th of June. Okay, like today, for example. I'm speaking about today. Let's as example. So the power is down. You can see there is no grid. So the electricity has been cut. So and in the second chart, you see this is actually the demand if there is a supply going on. But unfortunately, there is no any supply. Okay, so this is an example. We're going through the modeling and evaluation. So before I recommend any system, so I did like a technical, environmental, as well as economical analysis. So I have to make sure that I have the criteria to analyze any system or any scenario against the current grid system I've just modeled. So these criteria about like the load shedding is very important. I need my system to cover at least the 8 hours a day from 9 to 5, because this is one of the most important element in the system is to cover 8 hours a day. Also the renewable fractions, I need a high renewable fractions in the system. And the CO2 level, I want to make it as low as possible. And the cost of electricity, as lowest as possible, and the payback period as well, and the capital cost. It should be like kind of like, you know, acceptable and affordable for investment. So this is the important message here. The system scenario for this integrated system, I actually focused on the BV and grid. Another scenario is AD and grid. Another scenario is AD, BV, and connected with the grid. And the last options, I put AV, AD with a battery. So I will completely get rid of the grid, and let's see if the battery can cope with the demand. So this is the main 4 system scenarios you have to create as a researcher. So you have to make sure that, you know, you test the capability of your system to cope with the demand. Okay, so we're going to go through one by one. I know a lot of technical knowledge here, but the thing I have to go through it because it's really important to talk about it. So when we talk about the first scenario is the BV grid, you see actually from this schematic scenario. So the solar is basically providing a direct current to the town, and you have to convert it through the converter, and then it's going to be an AC, and then be sent back to the demand. It's automatic system. So how it works, if it connected with the grid, is basically if there's any surplus of energy, it's going to be sent back to the grid. And if there is high demand during the peak hours, the grid could have the support here. So you can see through this system is basically 83% of renewable fractions. Okay, and that as well, there is no any waste energy. There is surplus. Yes, the system is really high, 49% of the system going back to the grid. When I size the system, is basically I choose like 15 megawatt of PV, so it's going to be like a PV farm. Okay, it's not just like a single like a panels. I'm not speaking about like house level. I'm speaking about town level. Okay, so it's a big scale town. Okay, so it's 15 megawatt of PV. I compared it with other options of having 25 megawatt. At the end, just like to summarize this point, I found that 25 megawatt PV is better in terms of the reduction of CO2. In terms of the price, the electricity price, I got like 0.007. So this is really cheap electricity, you can produce through this system. So if I'm an investor, I would recommend using this system. Yes, it's very, is profitable because you can sell back the electricity, but I'm going to talk about the policy later. The initial capital cost for this system, BV plus the grid, is basically $42 million. Okay, you might be a bit scared about this number. I know that, but the thing is, it is at the end, it's an investment. It's a commercial project, So you have to be like business wise here about the numbers. Okay, so and the payback period is 8 years. Okay, you can get start getting the profits. This is how the system works. Usually, when you test the system, you need to test it through the day. So you have to make sure that you have the capability to overcome the load shedding during the day from 9 o'clock till 5 o'clock. You can see the system is coping well. So you can see that the red is the BV, in the morning is generating and starting absorbing energy, and then covering the demand. And there is like a mid energy of like 1 hour between 8 o'clock to 9 o'clock. This is one of the disadvantages about this system. I'm going to talk about it later. This is a typical day in Astana, by the way, on the left side. Okay, on the right side, there is a winter example of a day. So you see the demand usually in the winter is really small, it's not quite high. So the BV was able to accommodate easily the demand, and there's a lot of surplus actually. Going to be sent back to the grid. So in the winter, we don't have any problems. The only problem I got about the early morning hours, I can't cover it. And I need to find a solution about that. I'm going to speak about it later. Second scenario is only if we rely on the integrated system of AD, like Aerobic Digestion system, directly to the grid without any battery. So I found just in general, this is some information, technical specification. I can't go through all of them, but I'm very happy to answer all the questions at the end of it, how you calculate the CHP efficiency, the biogas basically the digester, how to choose the capacity of the system. In order to like implement any system, I was involved in a system here in Scotland with a company. They were actually working on how to maximize the capacity of the digester to absorb like a more feedstock, like waste from surrounding areas. So this is a good project as well to to know about it, like how to maximize it, like more energy from more waste. So the average is basically you can see from this system, the renewable fraction is only 17%. It's not quite high, to be honest, because why? The reason behind that is the capacity is very small. It's only like 500 kilowatt. So it's not that high. The consequences for that is basically because of the 5,000 tons per day, per annual, sorry, for the waste. It's not quite high waste in terms of the analysis. So that's why the system is not quite good. I wouldn't recommend this system alone. Okay, so this system can be connected to the grid directly. It wouldn't be able to cover the demand. You can see there's a big energy power coming from the grid, 83%. That's not acceptable at all. If you want to have like a sustainable option, a sustainable system, you need to rely heavily on your sustainable products, not on the grid. So I'm going to talk about it later. How the performance going on as well. You can see the system cannot cope with the demand. There's a big variations between them. It's all, the system has managed only to cover like less than 10%, and so yeah, it's really disappointing, this system, I would say. So we're going to talk about another system, which I recommend. This one is having like an integrated system of a BV farms with the aerobic digestions connected through the grid. You can see this system has got like a renewable fraction of 91%. The vast majority of the productions, power productions, comes from the BV, 85% capacity factors. And when we compare the CO2 level, like you see here for like in table 48 on the right side down, you can see the actually there's 80% reductions of the system of the CO2, which is could be like very visible. So from 17,000 like tons per annual to almost, let's say, 3,000. This is a great success in terms of CO2 levels. So this is one of the point that you have to take into considerations when you design the system. How about the initial capital cost? The total initial capital cost of this system is $52 million. Okay, I know you will be shocked about the number as well, but I say you have to be business wise about it as well. You have to be honest about it. Yeah, it's quite costly, but you need to take into consideration that you need to rely on like foreign investment. So the payback of this system is 8 years. How this system performs, you can see easily here on the left side of the power performance. You can see the BV and the AD could have managed actually to cover like the power supply from 8 o'clock till even till 7 o'clock in the evening without any problem. So this is a great. People wouldn't have any problem during the peak hours. So they will easily cover the demand. You can see on the right side in the winter, there's a lot of surplus, and this is going to be sent back. And as I said, it's going to be a commercialized system, so you can get money from it, but only if we change the energy policy in Sudan. Actually, I'm going to talk about it later as well. So this is just how the power performance is going on. Let's move to the last system. It's basically BV, AD, and battery. So these options, if we would like to get completely rid of the grid, we are not going to rely on the grid because it is unreliable. So let's have a battery, like a big size battery, a lithium battery. Could add like more stability to the system. The ability to dispatch the power in the night is far more greater than the other type of batteries. This is Canadian battery, one of the famous batteries in the world. So when you size the system, make sure that you have the ability to overcome the peak. Always focus on the peak. Okay, the peak during the day. Particularly in the summer. So that's actually is different from country to country. So it depends on the town you analyze. It depends on the system you follow. You can see the renewable fraction here is 100%. This is really good as well. So I don't need to have any reliance on the grid unless there is a problem with the battery. But in this case, there is no any grid. So 100% renewable fractions is the initial capital cost is $37 million, and the payback period on 12 years. So you can have a profit after 12 years. So this is good commercialized system as well for investment. How the system works in this part, I'm going to speak about. You can see the battery is going well. Is discharging during the night after 7 o'clock. You can see through the summer. And the only problem here I could see is the unmet electrical load. There is between 1 hour to 2 hours a day. So if I'm going to implement this system, I have to be honest with people as well. It's going to be like there is a 2 hours of load shedding. There's going to be 2 hours of blackout, either in the early morning or in the early evening. So this is, you have to compromise at the end, when you choose a system. So yeah, it's a great system, but unfortunately there is an issue with the unmet 2 hours a day. Just to summarize all the system, here is the result I found through this system. So you can see in terms of the renewable fractions, the renewable penetrations, and usually you calculated how much power comes from renewable sources. You see scenario 4 is great because it's not relying on the grid at all, 100% fractions. Scenario 3, which I recommended, is 91%, which is great. And the load shedding coverage. So as I said, the main problem in this project is people struggle every day from a power cut from 9 o'clock to 5 o'clock. So you can compare the system. Scenario 4 could cover it 100%, except there is 1 hour I said in the early morning. Scenario 3 could cover 8 hour, the 8 hour completely without any problems. And scenario 1 and 2, there is still a problems in terms of the coverage of the load shedding or the blackout. In terms of CO2 reductions, you can see scenario 4 and scenario 3 have performed better than others. In terms of the cost of electricity, all of them actually is still far less than the current energy system in Sudan at the moment. I'm talking about the production price, not the selling price, because the selling price is related to the subsidy government policy. Okay, so I know the government at the moment is basically subsidizing the price from $0.16 dollar per kilowatt hours to make it very cheap. I don't know the number exactly. I mean, someone can remind me at the end about the price, the selling price of electricity in Sudan at the moment. So, but in terms of this system, it's very competitive, it's very profitable. You can see the price is still less than the production, the production rate in Sudan. So it could be a great example if there is a foreign investment, you take the lead and you invest and you go ahead with this feasibility. The payback period is great as well, 8 to 12 years. So I would conclude in this study, there is scenario 3 of combination of integrated system of solar PV plus aerobic digestions connected to the grid is far better than other systems. Okay. Also, you can choose the if you don't rely on the grid because of there is the big problems. So then you can use a battery of that. So scenario 4 will be better in that situation. So it depends on the circumstances. Okay, you choose your system. I did also a uncertainty analysis just to see if my system will cope in the future, if there is any future variations for the future load shedding. For example, if the grid became unreliable completely, 50% of the day, there is no power 50%, and there's a big problem. So I could label the system as unreliable. So I wouldn't rely on the government decisions. I will implement the BVAD and the grid system. If the government, let's say, investigate and let's invest it in kind of upgrading the current existing system. So, and the power output became 10% or let's say to 30%, that's quite acceptable. It could be. So at this point, I would say, you could use a battery as a backup. So it depends on the situation. So you have to do a future uncertainty, and this is really important point for the investor as well. If I'm going to invest my money, I need to make sure that, okay, after 5 years, is it going to be the same price? Is it going to be any fluctuation in the selling? Is it going to be any problem in terms of load shedding? So I have to do like a price sensitivity, and on the right side figure, I did like a visibility analysis to see exactly how the payback period could be dropped down and if the price increased. So if the government take a decision to increase the price, okay, at the moment, that could benefit highly the investors and as well as people in terms of getting more stable electricity, affordable as well as sustainable. So this is the conclusion. Basically, let's conclude is the PV system is great in Sudan. It's crucial in any analysis. So the configuration of the system could be one of the most desirable system in the world. The aerobic digestion system is great as well, but the only downside of that is basically the limited amount of organic waste. So I have to make sure that I have the strategy to expand the waste, from surrounded areas. The system of BVAD is great connected system. It works well with the renewable fractions over 90%. So as I say here, also the capital cost might seem very high. Yes, that's true. The thing is, in any project, in any renewable projects, you need to rely on you need two things. You need the government policies and subsidy, as well as you need the foreign investment. So the government has to open up the market for international investments, because otherwise you wouldn't have any competitive electricity price. So this is what I concluded from the projects. Quick recommendations and future works. There is a limitation in this project, of course, but the thing is, I didn't do an analysis in terms of logistic analysis where I'm going to choose my BV system going to be the farms. I didn't do environmental impact assessment for the locations, the construction site. So I would appreciate if maybe someone who can build on this project and do a lot of analysis. Also, there's a recommendation how to increase the feedstock. So if I need to get more organic waste from surrounded area, I need a partnership basically with the local authorities, because without the local council, you can improve the waste management infrastructure. So it's really important point. I didn't do a biofilterizer analysis. As I said, one of the outcome of this system, you can have more digestate. We call it biofilterizers. You could use it for improve the quality of the soil. So this could be one of the recommendations. The demand reduction technology is part as well. If you want to replace the the design of the facade and the residential buildings, or maybe replace the current lights to LED, more efficient, more energy efficient, that could be one of the options. In terms of incentives and contract, I would say I would recommend these two important policies in Sudan: the FIT, the BPA. The FIT basically is a feed-in tariff system for any grid-connected system. It's a commercialized policy. The government could put it in the next 10 years. It's their policy to improve the incomes of the users, as the generators, as well as the suppliers. So the feed-in tariff, you can basically, the government will pay you money when you send your surplus back to the grid. So this could encourage a lot of people in Sudan having smaller scale of renewable systems. The BBA basically is a power purchase agreement. So this is linked usually with utility power generation. Is a nationwide scale, is a big scale. So you need the government to intervene here, to say, well, if there is any foreign investment going to implement a big, let's say, biomass projects, or the Ethiopian dam, for example, projects. So this could be profitable, having power purchase agreement. So the government will, basically you will sell the electricity to the government, and then having competitive, market. So this could open up the opportunity for foreign investment. So this is what my projects, and I conclude with this point. And yeah, thank you very much. If there is any questions, I would be happy to take it.
Thank you very much, Mogdad. Honestly, a great presentation. I really enjoyed it. I really enjoyed the flow of your research, because it reminded me of a lot of things I did when I was doing my master's research. Very impressive, honestly, very impressive work. And how long did it take you to do this research?
More than 3 months.
3 years, 3 months. يعني ما شاء الله صراحة. It's really impressive work, quite detailed. And one of the things I liked, honestly, is the methodology in the beginning, where you actually explained how you came to select the technologies. So through a systematic process, so impressive, uncertainty analysis as well. يعني ما شاء الله, really good. I think if you just add a few more things, you'll be eligible to defend this as a PhD dissertation. Great job. I think
Thank you very much.
there's a number of questions actually here, and a discussion has been going on in the chat. I don't know if you managed to see very interesting discussion. We'll come to that.
No, actually, okay, have a look.
But before that, maybe this is an opportunity to welcome the new people who joined us. We have actually a couple of interesting attendees, Mrs. Nazik Al-Hassan from the International University. We also have our team members from the Clean Energy for Africa team, Engineer Musaddaq Zain, co-founder Zulfa, Rashid, and our programs manager. They also joined us, so we welcome them. I will leave the floor to the questions, but I have just one question, and I already know the answer. But I want to hear from you because I think this is very important. So throughout this research, which mashallah is very detailed, very quite complex, a lot of results, mashallah, a lot of conclusions. My question is, what was the most difficult thing for you as a researcher in this project?
That's a great question. So I think the most important point was having a problems in collecting the data from Sudan. I mean, when you choose a project in Sudan, in your beloved country, you need to make sure that there is enough data, about the consumptions of electricity, about the specific figures from ministries. But unfortunately, that was a big barrier for me.
Okay, I think we could start off with a few questions from the attendees directly before I take the written questions. So if anyone would like to ask something, please unmute yourself and just introduce yourself and then ask your question.
Yeah.
السلام عليكم.
وعليكم السلام ورحمة الله.
أنا اسمي محمد بابكر, CEO and founder of Waira Group. Thank you very much for the nice presentation. I was eagerly waiting to attend the presentation. ما شاء الله تبارك الله, well done. واضح إنه there's a great effort has been made. And I've been working in the renewable energy for 20 years now. I got my master and PhD, graduated from Washington State University. We've been working on renewable energy applications. So I found this presentation very interesting. And I just need to share some of the constraints of the renewable energy application in Sudan and in Africa generally. I've been over many African countries. I went to Rwanda, south of Sudan, went to Ethiopia, and also I went to Bahrain. One of the biggest constraints we have in Sudan specifically is the awareness of the renewable energy application and the advantage and the use of the technology itself. Lack of legislations from the government. The lack of the standards. We don't have well-trained human resource factor. If you need to adopt any technology, you need to have people that can deal with it in different scales. So, and the funny part, by the way, while you're doing your presentation, I'm sitting in my house. I have 5 kilowatt hybrid system installed, and the power is gone. I've been working on solar battery system right now. As we speak, I'm using my solar solution in my house. So to get back to the subject, it's so difficult to transfer technology and convince people to go for it. If we need to pick just one sensitive topic, the agriculture. Sudan depends on agriculture right now. Gold mining. These two sectors has been impacted so bad with the diesel cost, and a lot of projects has been suffering through a lot of damages happened from the lack of the diesel supply. We import diesel in Sudan. If you go to Darfur, if you go to different areas in Sudan, there is no grid power. People use diesel generation to power up their homes. So I just need to highlight these difficulties I've been through personally in Sudan, trying to convince the government to go for renewable energy applications. We're talking about more than 15 big investments in Sudan working on the agriculture sector. Their projects, they cannot supply them with diesel. And they're implementing a lot of employees, and they're exporting the alfalfa to the Gulf countries, but they're still suffering from the diesel, from the poor supply, and they don't want to invest on renewable energy. Can you imagine if these companies right now, and that's one of the biggest challenge they're facing to go to phase 2 in their investment. We see the Raji, we see many investors came to Sudan. They've been granted big lands to raise the alfalfa or to do whatever they want. They could not move to phase 2 because of the lack of the electricity. Even if you have a power grid, there's a lot of overload. This is real scenarios. I just been also putting together a project similar like yours for West Durman. There's areas in Durman, Gharb Durman. There's no electricity at all. Schools, they don't have light, houses. These people, they suffer so much. So how are we gonna put this together to implement this kind of projects in Sudan? We need to think, to look at it from the bird eye, to look at the whole problems. It's not just the investment or the initial cost of the solar. By the way, I'm Jinko Solar distributor in Sudan. I have 5 megawatt right now in my warehouses. But when you look at the sector that work in the solar energy, most of them are not specialized. We don't have even one certified technician with the international standards. A lot of projects has been made with bad solar panels being imported from outside, low quality. Risk has been associated with these projects. Disasters happen.
I think there's a lot of work that needs to go into as you said, the legislations, the standardizations.
Exactly.
Man, there's a lot that we
go to Hurriya Street. Go to the Hurriya Street. Everyone is getting solar energy.
I agree with you.
But I mean, we need to just to conclude my my comments, because I want to let the others to talk as well. I just want to make the discussion more interesting to you guys. We need to engage universities. We need to have programs in renewable energy, like in wind energy, solar energy, biogas, just like the North American Board for Renewable Energy Practitioners certifications or whatever. We need to adopt these technologies. We need to learn from countries that start doing this business not far away, but they went through a lot of issues actually, like Egypt and UAE, other countries. Now they start implementing big projects in renewable energy. What about the waste?
That's right.
No one is talking about the waste. How are we going to deal with it? No one is talking about licensing. If something went wrong, who's going to be responsible? What's the legal part on the whole equation? We don't have even an association for renewable energy in Sudan. Even within the private sector, everyone is working alone. I personally built one of the first bigger water stations powered by solar energy, funded by Sheikh Mohammed bin Zayed in Eastern Sudan. You will be stunned when you go to these areas in Sudan. No energy. So this is a very sensitive topic, and I hope this is going to be the first one in the series, but we need to pick different topics to talk about it. We need to talk about the training. We need to talk about adopting the technologies. We need to talk about the manufacturing. We need to talk about the constraints from the government, the legislations. We need to learn. We need to, raise generations that depending on renewable energy. There is no way out for us in Sudan, without renewable energy. That's a fact. People, they don't get it. Diesel won't take us anywhere. Thermal won't take us anywhere. Even the hydro, because the cost of the generation and distribution is maybe 4 times the cost the generation and the transmission is very costly compared to the renewable energy. We're talking about mini grids, micro grids can be implemented everywhere. So thank you very much.
Very good point, Engineer Muhammad. I'm really happy that you attended. You brought this up, and honestly, I like the energy and the emotions in your words, because sometimes we really need someone to push us using that.
I lived it. Believe me, I lived it. I've been chasing this for a long time. I'm just very emotional because I'm very happy right now to hear someone like you, mashallah, tabarakallah, step forward, start talking about your projects. This is just your first step in in a mile, basically. You know what I mean? So
that's right.
You have all my support. You have all my experience under your tip. We get, inshallah, tabarakallah. Even if you need a job, let's talk about it as well, inshallah. No worries. But keep it up. Keep pushing forward. We need young guys like you, inshallah. Barakallah fikum.
Thank you very much, Dr. Muhammad. Actually, inevitably, without any doubtfulness, I think you completely agree with your points. You can see a very honest voice. There's a lot of issues and technical issues, the lack of expertise in Sudan, but hopefully, let's just put the hope up, and we're moving forward toward it is still immature industry in Sudan. So
correct.
Hopefully, as Dr. Muhammad said, we're moving forward toward it's a step by step, inshallah. So that's great. Yeah.
Thank you.
You're welcome.
Do we have another question or comment from the attendees? I think there was someone else who wanted to speak, but
yes, here. Hello.
Yes. Hello. Yeah.
Yeah, this is Zulfa Rashid, master graduate of engineering management and the solar advocate, co-founder with Dr. Muhammad in the Clean Energy for Africa blog. So it is very interesting presentation. And just like most of us here, I was really waiting for this because I'm really interested in solar energy. And thank you for Dr. Muhammad Babikir for raising these challenges. I think it's very motivational, as well as it gives us more power to understand how big is this kind of project. So actually, I have 2 questions. The first one about the duration of the collected data about the electricity consumption. I'm using actually my mobile, so I'm not sure if it was for 12 months or it's only January and December. And for how many years? The data collected, for how many years you've been analyzing this electricity consumption. The second question is about the location to install the PV modules in Sudan. Did you consider that part of this project? So these are my 2 questions, and thank you.
Oh, thank you very much, Engineer Zulfa. I appreciate your questions, and this opportunity is great to answer it. So in terms of data, let me answer it. I did a data, a survey, quantitative and qualitative survey for a whole year, basically. So I relied on 11 houses, basically, 2 schools, 1 hospital, as well as the pharmacy and the police stations. Okay. The thing I've used is basically there's part of them assumptions. There's part of them from real people who lives in the houses. So asking for their electrical bills over the last 12 months. Okay. So you gather all this in a central database, basically. So one of the challenges in Sudan, I could explain it clearly, is to have an official data. So in UK, for example, here, if I want to have a data about a specific location in Glasgow or anywhere in I would just go to the council. I would use the local council website Then I will just go to their website about like, okay, energy planning and urban design, the department, and then they will give me the data about any data about the waste, about the demand, the consumption for typical house, whether it is terraced house or semi-detached house. So it's really challenging, I agree with you. But for my data, I collected for 12 months, okay? According to 11 houses and the other rest of the sectors as well. And part of the data as well, I got it from consultations with experts working in the authority in Sudan. So just to give me the average, I need the average of the consumption during the summer and during the winter, because to make your analysis more accurate and solid or robust, you have to have like two analyses, either a summer or a winter, and it will be perfect if you combine both of them. So this is in terms of that data. In terms of the location, unfortunately, I didn't do like a logistic analysis and choosing where my farms or the wind or the PV farms or the aerobic digestions is going to be located. I did analysis for the land, okay, but in Sudan, usually you need to take a permissions for the land. You need to deal with the local authorities. So a construction site, you need to do like EIA, like environmental impact assessment. So I didn't do that actually, and I put it in the recommendations for future work. If someone interested to keep going with this project can follow up, and there is no 100% like project. Every project got limitations. So this is one of the limitations, the specific locations and how you're going to deal with the local authorities in terms of the regulation and permissions in terms of land.
Thank you. I think someone should continue, or maybe yourself should continue from this point to the logistic side as you recommended, because I think this will be, inshallah, very successful project. Thank you, Mogdad.
Inshallah. Thank you, Zulfa. Thank you very much.
Thank you very much, Zulfa. Do you have another question or comment?
Assalamu alaikum. Can I have a question?
Yes, تفضل.
Assalamu alaikum, Mogdad. My name is Abdul Hamid Tariq. I'm graduated from KFUBM, a master degree, specializing in majoring in power systems. Actually, I've been working on 2 or 3 projects like your project, like a feasibility study for using the integration of renewable systems, but in different locations. I'm very thankful for your project because it was in Sudan. So it shows the ability of doing this project in Sudan and its visibility. And that's really promising that from this project and moving forward. My question is for you in the design or in the feasibility study itself. How is your selection for the batteries and the type of the PV panels? Like not the selection exactly, but how did you cost it? Like how much does it cost for each one? How did you get the value of it? Did you ask someone or did you find it online? And because that made a huge problem for me when I was doing my research. That the amount of money that needed for each and every PV or the battery itself, that was a huge problem for me. So if you can help me with that, that will be like a great information for me. Thank you.
Nice. Thank you. No problems. So that's a great question, Abdul Hamid. Thank you. I appreciate your question. So in terms of the in terms of battery, when you size your system, basically you have to use like a comparable case studies. So in Strathclyde University, we got like a central database, like Energy Institute for like research. So we have got like a various application in being implemented in other developing countries. Like there is an interesting project was implemented in Egypt. So I took exactly the same description of the panels. Okay, so the type of panels I have used, the type of batteries, the lithium battery, what type of the particularly the Canadian one. Okay, one of the greatest I would say battery in the world, like the lithium one. Okay, it's quite costly, but it's really efficient. Okay, the ability to absorb these and absorb and also with a minimum like a DAC like losses. So I would appreciate, I would recommend that. It's like, go to University of Strathclyde. There is the research center, energy research center. We got like a various visibility study for different locations in the world. So you can use a comparable studies and you can just refer it in your analysis, how to use exactly the, sizing the system. This is one of the things. Another point is basically you can have what we call it is like, data from the industry. So here in UK, there is like a various companies working to develop like high level of batteries. So usually they provide like data on their website, a specific specification, and just to help you out in your projects as well. So look at the industry, look at the research centers as well. Both of them, it could be a great idea to get your data from.
Okay. Thank you, so that, and that was really informative from you. And the problem, I had a very problem with the battery itself, because it's very costly, and it's like messed up the whole project or the whole feasibility study, like make it very expensive and not feasible. That's
particularly when you particularly when you calculate you do sensitivity analysis in terms of the
exactly
the cost. I've been through it. That's why I understand that.
I faced that question a lot, like through a presentation I present, like what to do with the battery, what did you do better, and I couldn't find like a real or a great answer for it. But it seems like the sentence that really helped like the project have been working or study. That's a good start, at least for something real and real that can be made as a project.
Thank you very much.
Thank you.
There was maybe just going back to the questions in the chat. One of the first questions that was asked was about in biogas and how to mitigate it. Or I think that the question means the emissions, harmful emissions from the biomass system, the AD, were these like is considered in your model or anything similar to it in your analysis?
I didn't get the question very well, actually. So
the emissions from biogas, H2 emissions. I don't know. I think it means H2S.
Okay. Yeah.
I didn't also.
Okay.
It's in the beginning, Mohammad Abdul Dafi. Yeah, he was asking about how much is the emitted H2 in biogas and how to mitigate it.
Great question. That's a great question. Okay, so in terms of biogas system, particularly the AD system, so let's just talk about the outcome. Okay, so in order to have a biogas, okay, so the biogas is like 60% methane, that like CH4, and you got like 20% like H2O, and you got HES as well, like a carbon sulfide. Okay, so the thing is, to mitigate them, you need to use a software. So during my when I use the software for the AD analysis, okay, when you put the amount of how much biogas you got, okay, it will convert it directly to tell you like, okay, this is 60% of the methane, and this is the percentage of the H2O, and this is the percentage of CO, okay. And the way of mitigations, I haven't actually put more information about it in my project, because I relied on the software rather than actual mitigation process, because I'm not specializing in the research here. Okay, I'm taking from a point that you can have the analysis. The most important things for me is to have like at least 60% of methane. Okay, so the others could be like additional. Okay, I didn't focus enough about how to analyze to mitigate the CO2 here particularly, or the H2O. So this is the point in terms of the research. Yeah.
Okay.
I have another question, please.
Hold on.
Yeah.
Just one last question. Yeah, I'm just wondering if you have your project as a research paper at some magazine or so, if you can like give us the link of your work, that will be like very helpful for us if we want to review it again. If you've done it as a paper or something. Or it's still a thesis?
Yeah, I got actually the PDF thesis. Yeah, you can. I will let Dr. Mohammed to share it with you guys. It will be a pleasure.
Yeah. if we do it, if you do it as a scientific paper, some conference or journals, that will be a great addition for you to.
Yeah, I'm thinking about that actually to publish it, but I'm.
Yeah, you have to. Don't just think. You have to do it.
Yeah, I've just graduated actually, so you know, I'm focusing more about the industry.
Let him enjoy يعني خلاص اللي يستمتع شوية بعد.
You will forget all the hard work.
Yeah, I know.
Congratulations, man! Congratulations. Yeah, I'm really looking forward to see it. Yeah.
Thank you. I appreciate that. Thank you.
Hi there.
Yes.
Hi. Hi, Engineer Mogdad. It was nice, really great presentation. I mean, I was reading your thesis today itself. Really enjoyed reading it. And I mean, I'm a co-founder of the Clean Energy for Africa, working with Dr. Mohammed. I'm working here in Sweden within the African European Development Agency. And it's about time actually, because as Dr. Mohammed Babikar said, about getting renewable energy in action in Sudan. So it's great having such studies, especially when we're all suffering from these blackouts in different cities. And I guess East Soba is not different from all other small towns in Sudan. And that's even in the capital as well. So yeah, great work. I've got a couple of questions, two questions. For the net present cost, how many years was it? For the project life itself? And
okay.
Yeah, go ahead.
Okay, so for the net present value, so we have actually standardized the system for 25 years. So this is a lifetime of the combined system.
Okay.
So you're gonna start getting the profit. You have to wait at least like 25 years. So this is like it's a long lifetime, but it is actually atypical internationally between 20 to 25. Most of the renewable projects between 20 to 25 years. So my project was 25 years lifetime.
Okay. And speaking about East Soba is a typical town within Sudan with 20,000 inhabitants. So where do you draw the line? Like, where do you go? If you got a grid which is totally unreliable and everything, where do you draw the line that you're going to make it totally off-grid system, not relying at all with any grid? Where do you think you could draw the line in terms of maybe the number of inhabitants, the electric load, and stuff like that? I know it might not be included in the study itself, but just a thought about your.
That's great, Mogdad. So the system basically, as I said, there is two scenarios for the system. For the one works with the grid, so BVAD connected with the grid. So any surplus will be sent to the grid. What I mean by grid here is the distribution lines that go into the city. So I found out in the study there is a substation. You have to send it to substation first before you can send it to the line. Okay, just to at least to step it up as a transformers. Okay, and send it to the line. So it has to be the system. It wouldn't be working without any substation. It has to be like a substation first, okay, to absorb the power, the surplus power, and then send it back to the line going to the city. So yeah.
Yeah, exactly. And in case where places, there are also places within Sudan, on towns and cities, where they don't have any grid at all. Totally remote. Where would you draw the line? Like, okay. Would you think like going totally off grid would be? I think it would be the most suitable solution.
Yeah, that's an important point. Yeah, the thing about the Sudanese grid is the ability. We have to testify the ability of the grid to accommodate more power. Okay, so if I want to make sure that I have because renewable energy basically is stochastic, power generation is going up and down, fluctuating a lot. So I have to make sure that any power that is going to the grid is able to accommodate it. We have a problem here in UK, for example. The grid is going from Scotland to England. There's a lot of problems. There are a lot of discussions about the ability to absorb more offshore wind turbines, coming to the grid. And one of the solutions they say, well, is we have to have like a smart, automated system. So shifting the demand ups and down. So when we have a lot of power coming to the grid, let's put the demand down, okay? so the grid can have more time to absorb what I mean here by the distribution lines, basically having more time to absorb the energy, and then we can send it back to the towns. So this is one of the solutions working on it. But generally, as you said, yeah, I agree with you completely. So the point about the testify the grid ability, this is really challenging. Yeah, we have to have like more information, because if I implement the system and I found that the grid can accommodate my power, so there is no point of the system, right?
Exactly. Absolutely correct. Totally correct. Yeah, I mean, it's nice. It was nice reading your thesis, and nice having you as our guest. I will probably want you more for lots of other series and other guests as well. So nice having you. Thanks a lot.
Thank you. I appreciate you. Okay. Thank you.
Assalamu alaikum.
Alaikum assalam wa barakatuh. Ismail, just before you ask your question, I just want to make one quick comment. This is a good opportunity for me. Mogdad Abdeen, who just asked his question right now, by the way, Mogdad, I don't know if you know him before or not, but he has also an amazing master's thesis talking about solar energy in Sudan, which I used to say it's the second best master's thesis about renewable energy in Sudan after my thesis. After seeing yours, mashallah, I think we need to add it to the list of the top 10 theses of the last 5 to 10 years. I mean, so his
mashallah
is pretty impressive actually, and it's also in our website. So his contact is there. So perhaps it's a good opportunity also to connect
Thanks a lot for your time.
That's impressive, Mogdad. Mashallah, I appreciate that. Honestly, the pleasure is mine, basically.
No, it's our honor. We'll make a team, definitely.
Inshallah.
Do I have to lower my volume here? Because I think I will not have any echoes or...
It's clear now. It's clear.
It's all right. Okay, very good. My name is Ismail. Assalamu alaikum rahmatullah. Actually, I've worked in the national grid in Sudan and the control center, and I moved to Dubai Electricity, and I got my master's from Bath, electrical power systems, and now I am in the national grid here, so control center here. So first of all, I would like to commend you for a job well done. This is a very impressive work, and this is actually a full package for a system to be working in Sudan. And actually, this is a true challenge for the load shedding in Sudan. So you have wondered about the grid ability to take a system of this size. This is actually a good question. Yes, you need to go and find out about this. But my question for you about what are you, in terms of costs. So are you considering government subsidy, or you are considering the local community, or are you considering the public sector maybe in Sudan as investors, local investors? Because so far, I don't think there are any foreign investors interested to work in Sudan, and so far there are no real regulations regarding an off-grid or an integration of renewables onto the Sudan grid.
Okay, so yeah, thank you, Mr. Ismail. I appreciate your questions. So yeah, in terms of who I'm talking to, I'm actually putting the project a bit more on the foreign investments. So try to approach them like in a way that okay, let's have a communications, let's have a collaboration with the government to implement this system. Okay, but the government has to put a condition as well, like has to open up the investment, not take it exclusively. The price is really, is very cheap at the moment, the price of electricity. So you need to make sure that if you have an alternative system, competitive system, put the policy for the price to encourage other people, like other investments, other companies from outside Sudan, so they could come and invest. So this project is mainly focused on foreign investment, okay? Because I can't rely on the subsidy of the government subsidy, unfortunately, at the moment. I know the situation is difficult. There is a transitional government. It will take a lot of time to make sure that we have target for the future for renewable projects. So I'm focused more about the international communities rather than the communities.
Okay, thank you very much. Good luck with that. It's a bit challenging in Sudan. We don't have any. Actually, there are regulations still not applied regarding other, I mean, integrating renewables or trade-offs of electricity in Sudan is still it's a monogamy of the state. So anyway, but your work actually is a blueprint for a startup company to start in Sudan, probably. So yeah, thank you very much.
I just need to jump. I need to jump, if you guys allow me, to this point specifically for the rules and regulations. As far as my knowledge, the public-private partnership and the power purchase agreement has been drafted a long time ago, but the government never passed it or tried to implement it on the ground. The only project has been built for complete renewable energy source as a PV system. It was 5 megawatt, have been built in Al-Fashir. I think this was like a year ago.
A few months ago,
so,
actually. A few months ago, actually.
Pardon me?
A few months ago, like in March, I think, or beginning of this year.
Yeah, it was last year, I think they started, and I was like following them closely because they imported the PV system from Jinko Solar, and I become Jinko distributor in Sudan. So I'm a little bit aware about their issues. So, but the rules and regulations needs to be drafted so people can invest. Until then, off-grid system will be, I think, our idealist proposal. You know, currently I'm putting together a project in West Durman, in Al-Fatih. They call it Al-Fatih areas. There is 1,000 households, each one looking for 1 to 2 kilowatt PV system as a home solution. This could be an affordable solution, and we can use the microfinance. That's what I'm putting together for these guys. And I engaged one of the banks, and I explained to him that they can invest in this project and let people pay off the cost of the system, like for a year or two. This will be very useful to do micro projects. And another issue I would like you guys to consider in the future to do similar presentation, and I can help you guys with the information as well, is the water contamination issues. When we talk about energy, we have to talk about water as well. Our community, the community in Sudan, they're suffering from both issues actually. There's highly contaminated water, and there is lack of electricity at the same time. So things, you know, these problems start to overlap with each other. So we try to put like a layered approach to solve their problems by using a nanotechnology water purification system and small solar pump. So if they have like a water network connected to their homes, that they can use solar energy to pump the water inside using solar energy. So if you have like 2 kilowatt system, 2 kilowatt hour system, and a small half horsepower solar pump, I think you should be self-efficient and self-sustained. The sad part is, like I said, it comes down to the awareness. It comes down to the ability for the simple people to invest in this kind of technology. So we have to engage banking sector. We have to engage businessmen. We won't say it's a subsidized, but they can lower the cost and they can capitalize over the years. Another issue also on the renewable energy, I've seen this project has been implemented in Rwanda. In Rwanda, they don't sell to you the system, even if it's a micro or a microgrid or standalone system. These companies, they rent the system to you, and they put like a digital meter And you pay by you pay by tokens.
Yeah,
It's very flexible.
I know that. Yeah.
You know, and we need to see things like this implemented as well. So instead of let the household buy the system, you can lease to him the system and have him pay by tokens. And this is one of the ideas I think it might help to provide energy in Sudan. And one of the initiatives I personally put together is for schools, you know, to provide schools with energy, water, and communication system, so our children can go to school and learn. These are super duper small things we can put together. So I encourage you to engage with people like me who's been working in the ground, so you learn more, Mogdad, about the actual challenges. So this research is amazing, but you need to tune it down so it can be implemented, inshallah. Another thing about the foreign investors are the deterioration of our national currency. That's very important factor you need to consider, because people get paid here in Sudanese pound. And you know the dollar value versus Sudanese pound is always changing.
Ups and down. Yeah.
Exactly. So this kind of investment it's very challenging for them. I have very solid data about Al Manar water stations being built in Durman. Has been built by Water. It's a UK company. And I met the GM of the company in the past. His challenge was to regain or to get his money back, because the contract with the Sudanese government was in Sudanese pound. After 6 months, these guys, they were collapsing. So can you imagine the escalation will be like every month for the investor? So you can pay him back. It's not gonna work.
It didn't work. It's not gonna work.
It's not gonna work at all. So these are real challenges we're facing every day. And you know, I've seen a lot of projects right now. When you quote someone for a system, by the time you install the system, you'll be losing money.
That's right. Absolutely right. Yeah, absolutely right.
I just try to make things real. So all the participants.
These are very good points, Dr. Muhammad. Thank you very much. You're right. And
so
what the conclusion here is that definitely there is a need for innovative business and finance models to scale.
Exactly.
Not just
it has to be flexible.
Yeah,
we have to connect the dots together. This is a group effort, by the way. It's not just the government. It's not just the private sector.
Exactly.
It's a group effort from everyone. We're talking about educated people, awareness. We're talking about private sector. Talking about government. We're talking about legislation. We're talking about training. Training is a very important factor. Till this moment, many people, they don't know about solar. They just tell you it's not going to work. It's not going to work. We have been labeled. Do you know why? Because the small projects has been implemented. It has been implemented wrong. Whether it's a design issue from the beginning, or an installation issue, or quality issue from the materials being used itself. So these are the real constraints that really affecting the renewable energy sector and all kind of projects, whether it's small or big.
That's absolutely right. I mean, thank you, Dr. Mohammed. I just want to clarify like 2 points, okay? Just, commenting on Mohammed Babikar. So the first point is we have to close the gap. We have to bridge the gap between the researchers and the, industry and the, energy policies in Sudan. We have to put a pressure on the government that they could have like a target, because you can't start like a community energy system or like, implementing any type of energy systems without a target. Like most of like nearby countries, they put like a target for 2030, for example. Okay, let's say after 10 years, we're going to decarbonize like 30% of our like heating system, or our like, gas system, or our like electrical system. So you have to put a target, and then you can, you can start following up. The other point is basically renewable energy is not only solar. I see like a lot of people commenting on about renewable energy is just a solar. No, solar is just like 20%, you know, of other type of systems.
Correct.
Most of people, they just, I see a lot of articles talking about, like Sudanese articles talking about just solar in Sudan, solar in Sudan. I agree with that. Solar is, you know, is a huge benefit. It's great, you know, great system, but it's not enough. I mean, that's not the only options. It's very important to diversify your options in terms of supply and generations. So you have to have like you know, other type of systems. You know,
right.
I've never seen like a project about biomass,
you know
like
what?
a central biomass system.
Correct, but you know what, Mogdad? I need to add to this. Small wind turbines. I have done a project in Sudan with the small wind turbines. It's very effective. We're talking about from half a kilowatt up to 10 kilowatt system. It's very amazing. If any household can mount small wind turbine in his rooftop, it will supply him with enough energy. I just want to tell you guys about one example of a resort in Port Sudan. The owner of the resort, her name is Iman. She's very well known to many people that they go to Port Sudan. She's been using wind turbine for the last maybe 7 years to pour up her off-grid resort. It's been working fine. Can you imagine? We need also to focus on this. But I want to also tell you guys a story about Bahrain. I visited Bahrain back in 2018, and I met with the renewable energy sector. These are the guys who are drafting the rules and regulations and the vision of the Bahrain, the Kingdom of Bahrain for the coming like 10 years. So I found out these guys came up with very resilient and amazing idea. They have founded an energy bank. They call it First Energy Bank in Bahrain. Can you imagine this? Do you guys know the size of the Bahrain, correct? It's very small. But they have overgeneration. With their overgeneration, they have an energy bank in Bahrain specialized in financing energy projects. So why don't we have the problem of our banking sector? They're focused on real estate, for example, development. The bankers themselves, they need to be educated. The energy sector is very profitable. They never thought to finance energy projects. So we need transformation even in our banking. We need to educate these guys.
A lot of these sectors need to be in the like.
Thank you very much. We have a very long shore in Port Sudan. We have very long shore. Why don't we use wind energy there? We have high wind profile in Dongola. We have high wind profile in West Sudan. In Niala. In South Darfur. Why don't you use wind turbines?
Definitely.
So hello. Sorry for the interruption.
Yeah, go ahead.
Sorry to cut you off, but I'm just going to take few more questions from the chat. Hatim is one of the recent questions. He asked, he said in the beginning of the presentation, you have excluded or mentioned that wind energy is not recommended in Sudan due to the wind speed. I believe that coastal areas like Eastern Sudan may have higher wind speeds. Is there any study or have you come through any studies on that?
Well, actually, that's
the UNDP program about wind energy in Sudan, one of the largest renewable energy funded programs, focusing also on wind in the eastern part, coastal areas in Port Sudan state.
Well, yeah, that's a great question. I actually didn't exclude it. You can see in the presentations, I say it like specifically. So I have to be more specific. Specifically for this town with these situations, okay, solar is more better with the biogas than the wind, particularly for this town. Okay. I mentioned here the northern regions. Okay, usually, in the Port Sudan areas, there is a high chance you have high wind speed. But in terms of to do analysis for the wind speed, how to do that? It's basically, before you start a visibility study for wind speed, you do what they do, like 6 months monitoring for the wind speed. So it takes 6 months, like in an oil and gas system. When you have if before you go for a drilling well, you do exploration well for 6 to 1 years, just to make sure that you are in the system, and make sure that there is a potential for that. So you actually kind of measuring the wind speed in a specific height for 60 consecutive months. Okay, so this is the point, and particularly for these towns, from the comparable study, from the data I got, I found that there is no possibility actually to do that. I got better options for solar. I got aerobic digestion excluded for this town. But yeah, I agree with you. It could be implemented for other towns or in nearby countries. Yeah.
What about small and micro wind turbines, Mogdad?
There's also another question about that earlier on, written about micro wind turbines. So
yeah, that's a good question. The thing about micro wind turbine is as I said in the demand and supply analysis, you can have a micro wind turbine and you want to meet the demand of how much, 27 gigawatt hours annually. So you have to be realistic as well in terms of when you compare the demand and supply. A micro wind turbine less than, let's say, a couple of kilowatts or 100 kilowatt wouldn't be able even to cover 5% of the town demand. So because I'm speaking about the scale of the town, is it is a small town, yes, it is less than the city, yes, but you got 20,000 people living in the town. So you have to make sure when you design a system, you have at least wind farms, okay, small scale wind farms, small scale power PV system like 25 megawatts. I'm speaking about megawatts here, not a couple of kilowatts. So because of because of the system, the scale of the system, and this is one of the points I put in the recommendations. Before you choosing sizing your system, check very well the amount of the peak and the demand for the city or the town you're talking. I'm not talking about a couple of houses. I'm talking about city.
I think it's important to note here that the scope of your work was looking at the design of a system for a small town, not a home system for one. So in this case, the selection has to be appropriate. There was another question from Abu Bakr. He said, great effort, nice presentation. Had you included the cost of land needed for erecting both the PV and the anaerobic digester?
No, actually, this is when I put it in the future work, the logistic analysis, because the logistic analysis includes the EIA, the environmental impact assessment, and the land regulation. So I don't know how much it's going to cost for the land, because I didn't deal with I didn't find more information about the land exactly. So where can I take the permission to build this, and who shall I speak to? In Sudan, there's a lot of barriers. This is one of the problems I found during the study. So I would recommend if someone got information about that, that would be quite helpful.
And speaking, by the way, of information, I don't know if you can hear from Mrs. Nazik. I don't know if she's online. Nazik, are you online with us now?
Yes, hi, Mohammed. Assalamu alaikum.
By the way, Nazik, everyone is working as program officer, focusing on statistics with the International Renewable Energy Agency in Abu Dhabi. So Nazik, I don't know if you have some input with regard to the data issues and that we face as researchers or even as policymakers when it comes to renewable energy data, particularly for Sudan and for developing countries in general. I'd like to hear your input.
Sure. First of all, thank you very much, Mogdad, for the very interesting presentation. Unfortunately, I missed the first part of the presentation, but as the conversation went on, it was very interesting, and it was very enthusiastic to see that we have those kind of projects that are currently being studied in Sudan. I mean, this is one of the things that we try to do in IRENA. I mean, the whole point of the International Renewable Energy Agency is we try to promote, the idea is to promote different renewable energy technologies, and not only, of course, developed countries, but also, of course, the emphasis now is on developing countries as well. So it's very interesting and very enthusiastic, and I'm happy to see that this is actually happening behind the scenes. Because from the part that we see it is actually we're more now dealing with the institutional level at the stage. So the work that we do in my unit, basically, because of course it's statistics unit, so we'll try to capture the most recent data that we have for renewable energy statistics for Sudan, and in my case also other MENA countries. Several people mentioned on the call, the issue with the data availability is a really huge problematic issue in Sudan in general. But just to be fair, it's not only in Sudan, it's also in other developing countries as well. I mean, these countries are starting to get the grasp of renewable energy technology and so on. And like I mentioned in the comment, the problem is with those issues, it's mainly an issue that should be addressed as at an institutional level. So basically, we see in other countries, there is the statistical laws. Whenever you start a renewable energy project or so on, you register, for example, in a business registry. So there's some sort of ways to track the kind of projects that are happening in ground and so on. So mainly with Sudan, it's the problem institutions. Like I say, we're just trying to get a grasp of things from the government side. But the good thing is, like someone mentioned something about targets. So Sudan does have a national determined target. So it has a pledge for climate change initiative. So it has, I think, almost 20% target of total primary energy supply that should come from renewable energy by 2030. So the good thing is most of our NDC, what we call the national determined pledge, for example, for Sudan, is in renewable energy targets. So we have those targets in place, but those targets are conditional, and it depends also on how countries will basically provide us with support and so on. So we're getting there. The framework is in there, but I guess it's going to take time for Sudan in general to pick up the pace. But the good thing is things are happening, Annie. One more thing that I can add is we currently have a project between Arena and Sudan to help them improve their national determined submissions and so on. And of course, since the submissions is in terms of renewable energy targets, so there could be some sort of support and a pledge from other countries to chip in and open business to Sudan basically for renewable energy. So things are happening behind the scenes, but it's positive. It's going forward, but it's a matter of time. And
well, fingers crossed. Yeah.
The private sector, of course, involvement is one of the key aspects in this whole situation, and also awareness of the importance of renewable energy and the possibilities of things that could happen among everyday people. That's it.
That's great, Nazik, actually.
Report is coming up soon, Nazik, about the latest statistics for the for renewables in the Middle East region, if I'm not mistaken.
Yes, it's actually due by the end of the month. It's basically the global energy statistics, renewable energy statistic, not only for MENA, but for the entire global, for example, spectrum. And it's for all renewable energy technologies and some energy balances as well, the renewable energy balances for some countries. So far, we were, let's say 50% improvement from last year in terms of the energy statistics for Sudan. But it's still a struggle, to be honest. It's still a struggle, especially distributed projects is still a measure. So not right now, I'm actually learning from a lot of things that, for example, this wind-based project, I guess, I think Mohammed Babikir mentioned in Port Sudan, the resort. So that's something that I never heard of before, for example. So I'm sure there is a lot of projects that are happening at smaller scale, but
I see.
No one knows about them. So it's good that we're having those discussions with you as well. But thank you for this opportunity for me to comment as well.
Thank you. I mean, despite the fact that, as you said, like there is a continuous struggles, but it's a great news to have like there is a target. Sudanese, I mean, government got a target. Like I didn't know about that. 2030 got like 20% reductions in terms of climate change. That's great, actually, and that will be, I mean, impressive to publish more regulation and information about Sudan, because we don't have like a central statistical database. This is the thing. Like we need more like data, and great to have your comments, Nazik. That's brilliant.
Sure, thank you.
Hello, gentlemen. Can I speak?
Yes. Go ahead.
Yeah, hi. My name is Salim, and Salim. I was really trying to raise my hand and so on.
It's a pleasure.
But I'm having a difficult internet. I hope everybody is hearing me. Can you hear me?
We can hear you.
Go ahead, Salim. Yeah.
Right. Great. Thank you very much. I was listening to to most of the talking, which is great. I would really first like to thank you for the presentation and for the study. And I do believe it is very much doable. It's a very good base where a private sector, as it was mentioned just a while ago, to pick it up from somewhere. One of the greatest problem we are having in Sudan is actually data. And I do agree with Mohammed on that. But this is a very good and excellent starting point where we could, as a private sector, cooperate, collaborate somehow to come up with cases that the government would feel that this is really doable at the first stage. And in the second stage, talking to financial bodies and financial institutes that they can finance the renewable energy, specifically, precisely on the renewable energy, on the side of let me say, the agriculture or the production in general. Definitely agriculture and production, or the added value of the agriculture as well, of course, is a corp cash. As a corp cash, it's a generation of finance and money for the government, which would always be very beneficial for both sides, whether it's for the private entity or for the government or for the financing body. Excuse me. It's definitely a long-term investment, which is something between, let's say, 20 years, 15 years, 25 years, somewhere there, depending on the study and the capacity of going to be needed. We all agree that we have a serious issue related to two parts.
Engineer
the tariff itself.
Sorry, cut you off, but I think a lot of people don't know that you are the acting general manager for the Sudanese electricity transmission company.
All right. I
okay.
see. Okay. I was the acting manager. I was the acting managing director for. I was the acting managing director for Sudanese transmission for a period of 5 months. And this was actually as a request from the Minister of Energy and the Ministry of Energy and the government of Sudan to help them to put a 5 years plan for Sudan with other, of course, people to do somewhat of a vision, and which I have started it in to work on it in actually a little bit earlier. I started working on it in 2017 on my own and private interest. and I've been requested for that. I submitted it actually, and after with others, and after they looked on them, I had a call to help, to understand it and to see the way forward to implement it. And this was ended by February 2020. At the end of February, I stopped and I went back to my original job or my work, which I do, and I'm still doing now. I continued again. At the same time, I do believe I have understood completely that they have adopted the 5 years plan, which I have put it. Mr. Khairi, the Undersecretary, was talking about basically there is a plan for the government, which as the engineer before me 20, which some up on it. I'm not working on it at the moment, but the 5 years plan is asking for an increment in the renewable.
Mr. Salim, can you just repeat what you said, because your audio is cut off?
I think the line has cut off.
So sorry, I'm back again. Please bear with me. The internet is getting interrupted.
Just repeat the last 2 sentences you said, please.
Right. There is a 5 years plan, and a massive part of that plan is actually depending on renewable energy. And it is mainly concentrated on the areas where there is a production, which is normally out of the residential of Khartoum. So the government is very much appreciating to go on that direction. This is something I would definitely say yes, they are working on it. They are working with different entities: the UNDP, the German, the GIZ, the environmental bodies of the African Union, the Eastern African Power Pool. All of them are working on the same direction, and the legislation is the first part, which is actually started. It's started by the African Union by financing 2 consultants, which they should be appointed, and it was advertised in the internet and in the newspaper and in the website of the Minister of Energy. They have advertised for a consultant to work on the legislation and regulation of the solar system that will help the agriculture and irrigation system. Now, this is a very good start, although it does not give everything, but it's an excellent start. At the same time, just yesterday or the day before yesterday, Mr. Al-Badawi, the Minister of Finance, has announced that they are going to revisit the tariff of the energy in Sudan for the residential and for the commercial sector. So basically, the indication shows that, yes, we are moving on the right direction. The government is moving on the right direction. Now, it is up to the, I would say it's really relying a lot on the private sector to collaborate with the government, with the studying and research center, just like the gentleman, unlike Mohammed here, what he is doing. We have to work with him on that direction to reach to the optimum and the possible beneficial win-win situation between the government, the private, and the financial body. There is absolutely no way that the government could finance that huge generation, and it's complicated work which needs to be done by itself. We, the private people, we have to take part of this initiative. It's essential. I'm trying to work on this with different entities, with different places. I do believe it's not easy, of course, to get a financing company at the moment to invest in Sudan, but it's not impossible. Somebody somewhere has the interest. All we need to do is to have a good study with a good institutes and present it properly. And I do believe the finance now is much easier in the renewable than it used to be. And when you look at it with the curves which we have for the amount of heat that we are getting from the solar, the data which we have for the wind energy, definitely there is no losers. For sure, it's quite enough. I do believe that we have hiccups and we have some problems related to nighttime, related to morning time. But I do believe we have to start somewhere. Currently, we are pursuing a project of financing an agricultural area of, we are targeting about 10 hectares. We will see where we will end up, but we are moving between 5 to 10 hectares, self-finance externally, and on an IBB methodology that the owner of the land would pay only the electricity for the next 15 years. This is something I think it's a good initiative. It's not easy. It's very difficult. It's going to take us time, but we are pursuing it. And I hope it will be a module that will convince the government and other private entities that this worth trying it. It's going to take us lots of engineering, lots of studies, but I think we have made lots of joint ventures between different entities that they are capable of doing the engineering. Of course, I'm in contact with Mohammed and with the gentleman in Clean Energy for Africa, and they are actually every day they are I would say they are convincing me more on that direction. And I'm very confident that I have somebody whom I can rely on. This is very important, you know, somebody who has the passionate for it. So this is what I wanted to say. I'm sorry I took a long time, maybe, but I'm definitely optimistic about the future of renewable energy in Sudan. And I do believe in the next 5 years. I'm sorry, there is an interference of a voice. I'm very much optimistic that in the next 5 years, our renewable energy generation in Sudan would definitely increase from 40% of the current capacity which we have into something somewhere between 60 to 70%, because this is the future. This is what we can do, and this is what we have to do. The initial cost, the initial investment is high, but the operational, the capex is high, the OPEX is quite low, and I think we have to do it. It will help creating jobs. It will help improving lots of areas in Sudan, which they need. It will help improving the agriculture. It will help to build the added value factories that we need for our agriculture. So I will thank you very much, gentlemen, and we will definitely have lots of discussion more, and I will just leave the mic for somebody else. Thank you.
Thank you very much, Engineer Salim. Honestly, very, very insightful comments. Really. Maryam, I think you wanted to say something. Please go ahead. Maryam? Maryam, do you want to add something, or is you were heard your mic? الصوت ما واضح يا مريم، معلش. It's not clear. ما سمعته والله. It's not, الصوت ما واضح. If it's not clear, can you just write your comment or question in the chat, please? الصوت ما واضح بالنسبة لي. I don't know, Mogdad, I don't know if you have any comments or follow up on Engineer Salim's remark.
Let me check it. Let me check it now. You mean the question in the chat?
No, on Engineer Salim's comment right now. If you have any follow up, sorry.
I actually agree with him. I mean, he gave like a comprehensive analysis for the current situations, and great to hear from authorities, point of view. So the thing I would add to the point he said, basically, I agree the capital cost of any potential future energy system is going to be high, okay? But that is not shocking. That's not the end of the world, okay? There is other options in terms of, as he said, the operation cost and the maintenance running cost is actually like 1% or 2% of any potential capital cost. So it is quite low. Yes, I agree with him in this point. However, we just need as you said, all of you guys, we need encouraging the government to take more holistic approach. We need more awarenesses about renewable energy in Sudan and the community. You don't have to rely on central government decisions. We can always have decentralized approach, decentralized system. Okay, so I hope I could see more a potential projects going on. Because at the end, what we want at the end is, to help our beloved country, right? So I agree with him completely. Yeah.
Great. Okay. There was another question. Actually, I wanted to read earlier from Shireen. Going back to your study, Saddaq. She said, given the scenarios that you mentioned so far and your conclusions, what would you say, considering Sudan's situation now from different aspects, which solution or scenario you elect or suggest to start with? Maryam, I honestly cannot hear your voice. Mogdad, I don't know, can you hear Maryam's question? We cannot hear clearly. So maybe, Maryam, if you can write it in the chat, because there is a lot of echo and interference in your audio. We cannot hear your question.
I think she forgot her mic open. That's all.
Yeah, so maybe write your question in the chat that we will read it out. But in the meantime, Mogdad, going back to Shireen's question about the best scenario to consider for Sudan's situation at the moment.
Oh, that's a big question, to be honest. It's a vast generalization, I would say. But to take it, like, to break it down slowly, I would say there is no one system for whole Sudan. That is going to be kind of like madness, I would say. So you have to take it in a way that's like, specifically for, do you mean on a local scale? Do you mean on a town scale? Or are you speaking about nationwide scale? So there is a 3 different approach. So my project is actually about town scale. So if you're talking about, like, electrification of rural area in Sudan, I would definitely go with solar projects, okay? Community solar projects, small scale projects. So this could help, electrification of more of rural areas. Particularly when you take into consideration that 60% of the nations, could you believe that, Dr. Mohammed? 60% of the nations, they don't have access to electricity. Is actually kind of I don't know what to say, but it's a shocking news, isn't it? Yeah. So I would say for the rural areas, yeah, focus on communities, small scale, like, stand-alone system, not connected to the grid. Start from one house. Start from your farm, start from your agricultural pumping system. So this is one of the solutions for rural areas. In terms of like urbanized areas where there is kind of like there is already a system built in place, but there is a problems in terms of connections and regular blackouts, I would go for a central biomass system that could be connected to the distribution line, because the biomass is quite affordable in terms of having the feedstock. So you could easily get the waste, from surrounding farms. You can also help the environment in terms of having like a central recycling, authority, or like someone who could help out in terms of this problem. So yes, it depends on the location. They're going to be a solutions. You can't have like a one approach for the whole Sudan, I would say.
Great. I see we have 3 hands raised. Can I first ask Mr. Al-Sadiq? Please go ahead. Sadiq Osman.
Assalamu alaikum wa rahmatullah.
Assalamu alaikum wa barakatuh.
Sadiq Osman. Senior electrical engineer in Saudi Arabia, but I have I worked before 6 years ago in electricity section in Sudan as the rural electrification director. I start with the rural electrification with the standalone solar system. The first, I want to thank Mr. Mogdad very much about this interesting and comprehensive presentation. And I want to comment about 2 things maybe. The first thing, for grid connected solar systems, the main problem is the land. When you put it in houses or in government buildings, I think you will face some problems. I want to ask Mr. Mogdad, how can he manage so as to for these difficulties with buildings. For big scale, I think it is better for us to be in private land. Or governmental land, not in buildings. This is the main thing. The other thing, I want to talk about the rural electrification, because this is the main thing, and this is very important regarding what he said before. He is talking about the tariff. I think the tariff, this is the main problem, and because a big government subsidy was done to electricity tariff. He is talking about $16 cent, which is a big value compared with the actual tariff that is around maybe less than around 0.11 euro cent, and he's talking about 16 cent. This is a big difference. This is, I think, for feeding tariff, it is a big problem. But for the electricity companies was to build a big scale, like 25 megawatt by government. This can be, but the investment, it will be very difficult to get with this value. But I think if we want to get more investment, it is better so as to go to small scale, like solar home system, what he said before, because this is more visible, so as to because you know that Sudan is a big country, and we have a lot of people living in rural area, and the plan 2020, the long-term plan for electricity sector, talking about 24.9%. This is the long-term plan from 2013 to 2031. Talking about 24.9% to be covered by solar home systems by 1,100,000 solar home systems. Add to this one the pumping, water pumping for agricultural areas. This is what can be more helpful. And this can get more benefit for area connected with the network. The kilowatt hour is very, if you compare with the actual value, that what we are talking about, a big difference. But when we make this in the rural area, we will find many benefits. Another thing, regarding what Dr. Muhammad Babikir said, what I want to comment about, the experience in Rwanda. He said that there is a meter and he make a digital meter so as to collect the money for the electricity company. This is already done. This is already done in Sudan, 2014. And this is connected with our tariff system. As payment, monthly payment, we already make 100 pilot project in 5 areas, and any household will pay monthly installment. He will go to electricity office and he pay his charge, and they gave him a token, go back home and enter the token and get 30 days. After I think 2-3 years, this meter it will be cashed again, and the system it will be totally belong to him. But unfortunately, this I don't know until now what will happen. But actually, it is already connected with the network and connected with the system, electricity system. And at the end, I want to thank you a lot, and we hope that we find another presentation regarding solar home system and pumping, water pumping for agricultural project. I think this is what it give more benefits. Thank you a lot.
Thank you. I actually appreciate your question, Mr. As-Sadiq Osman. You actually summarized the whole points about this webinars, and there's a lot of points to catch, to be honest. But I will definitely agree with you. I couldn't agree more about the tariff system need to be changed, and also about rural electrifications in Sudan. So we need more about, like, standalone systems, and and for a bigger scales where there is an area of urbanizations like Khartoum and Sudan, big cities, we have like, we can have like a utility, like a power plant. In terms of the point, in terms of the aggregations and the pumping system, I think this is it's not my area of expertise. I think Dr. Mohammed Al-Haj could help you out, and he could answer this question, particularly how we can develop this, more like, pumping system, agricultural solar pumping system, combined system in rural electrification, because this is, I think, probably his area of expertise. So go ahead, Mr. Mohammed.
No, not exactly. Although we have one of our team members, Engineer Saddah, he's actually working on a small project now to evaluate solar water pumping systems. So maybe we can host him, inshallah, soon. However, it's now almost being like almost 2.5 hours, and I think I know that everyone is quite interested, so we will continue the discussion. But perhaps we could just conclude the formal session and end the live streaming, and we can continue because there's still a few hands raised. So I'm just gonna conclude formally, and then we can continue the discussion. But as I say off the record, we can also speak in Arabic. So to formally conclude, I'd like to thank first thing our speaker, Mogdad Abdeen, for this webinar, which is actually the one that had the most interaction since we started this series. So thank you very much. Thank you everyone also for attending, for your participation, your enthusiasm, and we're really happy about this in Clean Energy for Africa. Two final quick announcements that all our events, updates, webinars are regularly announced in our social media platform and also in our newsletter, which I invite everyone to register through this link I'm just posting here. Simply register with your email to stay updated about our work and everything we do. And we also have a short 3-minute survey to evaluate this webinar. So I would be very appreciate if everyone will fill the survey. Thank you very much. And now I'm going to end the live stream, and we can continue the discussion, everyone to their convenience.